Okay, moving on to the next section of chapter 3, we're going to talk about zeros of linear functions. And before we get into that, once again, let's go over our learning objectives. You're only got a couple today. First one, we're going to find the zeros of a linear function, and then we're going to model real-world examples by finding the zeros. So, what is a zero? A zero or zeros are the x values that make a function or an equation equal to 0. That's why they are called zeros. Now, zeros have many different names. Zeros are known right now, or the most recent thing that we've talked about, are x-intercepts. They can also be referred to as a solution, a root, and of course a zero. So they all mean the same thing. So if you hear one, they all mean another word. They're synonyms for each other. So like just in that last section, we were going over an x-intercept. We'd want to find the x-intercept. In this case, where we see, let's see, 1, 2, 3, 4. This crosses the x-axis at 4. It has an x-intercept of 4, but it's also considered a solution. 4 is an x-intercept. It's a solution. It's a root. It's a zero of the equation that's there, y equals 2x minus 8. And those are the numbers that we're going to be finding today. So how do you find a zero of a linear function? Well, there's two pretty simple steps. You might have a function that's written in function notation. That's the replacing f of x, or it could be written in y equals format. So either way, if you see an f of x or a y, you want to replace it with the number 0. And step 2, solve for x. It's like finding just like our steps with x-intercepts. So let's try an example here. F of x is equal to 3x plus 3. If I go with the steps that I have above, I am going to replace the f of x with a 0. So now it says 0 equals 3x plus 3. Move on to step 2, solve the equation for x. So I will subtract 3 from both sides. Now I got negative 3 equal to 3x. I'll divide both sides by 3, and I will get x is equal to negative 1. So that right there, I would say that negative 1 is a 0 of f of x equal to 3x plus 3. That is where this equation would hit the x-axis. We could also do this by looking at an actual graph itself. So here we got another function that says f of x is equal to 6. And I've given you the picture of it so you can see what it looks like. It's a completely flat horizontal line that goes on forever left and right. And look at it. Is it going to ever hit the x-axis? Doesn't look like it will. So sometimes if we get an equation that's not going to hit the x-axis, it doesn't have a 0, we call it no solution. Pretty simple there. And I can go back and do this with the equation where I replace the f of x with 0. And you can see, does 0 actually equal 6? No, obviously it doesn't. So that's another way to say, well, there's just no solution to this. 0 obviously does not equal to 6. Okay, why don't you go ahead and pause the screen and see if you can find the 0 for this linear equation. So if we go through our steps for finding the 0, step 1 said to replace the f of x or the y with a 0. Here I got an f of x, so I have a 0 now equals 2/5 x plus 6. Step 2 says solve for x. So I will subtract 6 from both sides. Now we're going to have an equation that says negative 6 equals to 2/5 x. Now the shortcut method of getting rid of the fraction is a term that we call multiplying by the reciprocal. Reciprocal is a fancy way of saying flip the fraction. So if I have 2 over 5, I'm going to flip it and make it 5 over 2, and I'm going to multiply both sides by 5 over 2. On the right side, the 2/5 and the 5/2 will cancel each other out and leave you with an x. Use the calculator to do 5 over 2 times negative 6, and you're going to get negative 15 equals x. So I have negative 15. That is a 0. It's a root. It is also a solution, and it's an x-intercept of the function f of x equals to the 2/5 x plus 6. All right, so how do we apply this 0 idea? Well, let's look at a word problem here. Willow is going to download a 2-hour movie. This function, y is equal to 1.5 minus 0.0625x. It represents the number of gigabytes that are left to download after X amount of minutes. How long is it going to take her to download this entire movie? Well, one thing that we want to look at is, here it says X minutes. We're trying to figure out how many minutes it's going to take up to eat up all the gigabyte that's left over. So if we're going to solve for X, the other variable Y is the one that we're going to replace with a 0. And then we're going to go in and solve for X so we know exactly how many minutes this is going to take. So first thing I'll do is subtract 1.5 from both sides. I'll have negative 1.5 equal to negative 0.0625x. We've got to get the x by itself, so we're going to divide both sides by the decimal negative 0.0625. And this should all work out since negative divided by negative is positive. Use the calculator, and it'll simplify to give us 24 is equal to x. So what is 24 equal to x again? Well, if I look back up at the word problem with the red box that I have there, it says x represents minutes. So this means it will take 24 minutes for Willow to download this 2-hour-long movie. And of course, since it's a word problem, it does require a word explanation. Give a short sentence of what it means. Of course, whenever you're trying to find zeros in a real-world situation, they're not always going to work out real nice like the last one did where we had exactly 24 minutes. So let's take a look at an example and see what happens here when we don't get a nice and easy number. So Emily is going to a local carnival. This function m is equal to 20 minus 0.75. R represents the amount of money m she has left after R rides. We're going to find the 0 and describe what it means in context to the situation. So basically what this comes out to say is that it's costing her 75 cents to ride the ride every time, and she went there with $20. So we're going to find out when she runs out of money. When is she going to end up with $0 left? So I'm going to replace m with the number 0, and I'm going to rework this to solve for R to figure out how many rides it's going to take. So first step, subtract 20 from both sides. We've got negative 20 equal to negative 0.75 R. Got to get the R by itself. Divide both sides by the negative 0.75. And when I use the calculator, negative 20 divided by negative 0.75 is going to give us a decimal. If I round it, 26.67 approximately for R. Now think about it. Can you just ride along on a roller coaster or any carnival ride and just go 2/3 of the way through it and say, well, I'm done. I'm getting off. Of course not. You're going to hurt yourself. So let's think. She's either got to ride it 26 full times or she has to ride 27 full times. Let's figure out which one makes the most sense. So let's say she goes 26 rides. 26 rides times 75 cents each is going to be a total of $19.50. She went there with 20, so far we're good. Now let's check for 27 times. 27 rides times 75 cents each gives her $20.25. That's 25 cents that she doesn't have. So she can't ride 27 times. She's going to have to revert back into only be able to ride 26 times before she doesn't have enough money. And hopefully that makes sense. So I'm going to go to the next slide. And when I get to the next slide, I want you to pause. And I want you to read through the next word problem and try this one on your own. And then when you unpause, I'll work through it. All right, so Antoine's class is selling candy. To raise money for a class trip, they paid $45 for this candy, and they're going to sell each candy bar for $1.50, and they've got a function to represent this. Y equals 1.50x minus 45. It's supposed to represent their profits, Y, when they sell X amount of candy bars. Now, we're going to find the 0 that describes what it means. So we got to first put in our 0. We put 0 in for the profits. And we're going to resolve this for X to figure out how many candy bars it's going to take before they actually start making money out of this. Got to isolate the x, add 45 to both sides. Get 45 equal to 1.50x. Divide by the 1.5. Use the calculator. 45 divided by 1.5 is going to give us 30. So what does that 30 actually mean? They were $45 in the hole because they had to pay to get the candy, and they need to get money back before, when do they make up the when do they make up the $45 that they spent to get it before they actually start collecting money for their own profits? It's going to take 30 candy bars before they actually make a profit off of selling these candy bars. And there you have it. That's how you use zeros to solve word problems.